In this video, we look at the features that make up Azure Blob Storage. Hello everyone, I'm Travis and welcome to my channel. An Azure storage account comes with a lot of features and functionality, including file, blob, queue, and table storage. If you're studying for a certification or work in the cloud, it's important to understand the storage options available in Azure. In this video, we look at binary, large object, or blob storage. Before that, please like, subscribe, and share with a friend. Your support is greatly appreciated and helps others discover this channel. Check out my courses on Azure Virtual Desktop, Windows AD and Enter ID hybrid identities, and Windows 365 with Intune management, available at udemy.com. And thank you, channel members. Your support is appreciated. Back to it. One early mistake I made in my cloud journey was not understanding the different types of cloud storage available. I worked in a Windows environment and used file shares. How different can blob storage be? Well, it's significantly different. Files and file shares have a directory structure accessed by a UNC path using the SMB protocol. Files in those directories have metadata attached to them and leverage some kind of access permission. Blob storage differs from file shares. There's no hierarchy or directory structure, and the files are accessed over a web address using the HTTP protocol. Blob storage includes metadata, but not like files on a file share. Blobs are simply unstructured binary or text data objects stored at a web endpoint. However, with Azure Blob Storage, we can store a massive amount of unstructured data. That data is available across the globe at an HTTP or HTTPS endpoint. That means we can access the data with web applications, APIs, and programming languages that leverage the Azure storage libraries. Let's dig deeper into the features that make up blob storage. We'll start with how blob storage is organized. There are three resources that make up blob storage. First, we have a storage account. This is an Azure resource that holds blobs, file shares, queues, and tables. We're focused on blobs with this video. Then we have containers that organize the blobs. Containers are like directories in a file system. A storage account can have an unlimited number of containers, but we can't nest containers within each other. The storage account and container name make up part of the URL. Names need to follow the standards for internet names. They can only contain lowercase numbers and letters and dashes. Also, a storage account name has to be globally unique. Then we have blob files in each container. Blob names can contain any combination of characters. They don't have the same formatting requirements as storage accounts and containers. The names are case sensitive, and because they are still available over the internet, any reserved URL characters have to be properly escaped. By the way, blob storage is based on a flat schema. It's simply unstructured data in a container. However, we can create virtual directories by using a / in the blob name. In the example on the screen, we have two images with party in the path, and one image with offsite in the path. This would create two virtual directories, party and offsite. Let's move on to storage accounts. We need to create a storage account to use blob storage. There are three types of storage accounts: standard, premium block blob, and premium page blob. Standard, general purpose V2 storage accounts are used for most storage workloads. We can use it for blobs, file shares, queues, and tables. All these services are available in a standard storage account. There are also premium storage account types that have additional performance for specific workloads. Premium block blob storage accounts are for blocks and append blobs. This is a good option for workloads that have high transactional rates and smaller objects that require low latency. Consider this for applications that write and read data quickly, such as e-commerce. It's also good for IoT and streaming analytics workloads. Premium page blobs are designed for random reads and writes. Page blobs are a collection of 512 byte pages, up to 8 terabytes in size. This is used for disks on IaaS VMs and other services, such as storage for Azure SQL databases. There's also a premium file share option, but that's not for storing blobs, so I left it off the list. Let's move on to redundancy next. Redundancy is important when we store data. Standard storage accounts give us the most options for redundancy with locally redundant storage, geo-redundant storage, read access geo-redundant storage, zone redundant storage, geo-zone redundant storage, and read access geo-zone redundant storage options. That was quite a mouthful. Premium storage is backed by high-performance SSD drives. It offers locally redundant storage, and zone redundant storage is available in regions that support zone redundant storage. Next up is storage tiers. Storage tiers are only available on standard general purpose storage accounts. First is hot, which is optimized for frequent access. It has the highest storage cost but the lowest transaction cost. Then we have the cool tier. The cool tier is optimized for data that's infrequently accessed. Data in the cool tier should be stored for a minimum of 30 days. Next is the cold tier. This is optimized for data that's rarely accessed and should be stored for a minimum of 90 days. Deleting, moving, or overwriting data from the cool or cold tier before the minimum days is subject to an early deletion penalty. Keep that in mind if using the cool or cold tier. And last, we have the archive tier. This is the offline tier for data that's rarely accessed. It's only available with locally redundant storage, geo-redundant storage, and read-access geo-redundant storage. Zone-redundant storage is not supported with the archive tier. Data should be stored in the archive tier for a minimum of 180 days. As shown on the screen, hot has the lowest access cost, but the highest storage cost. This is ideal for workloads that are frequently accessed. Archive has the lowest storage cost, but the highest access cost, while cool and cold fall between the two. The cool and cold tier are good for short-term backups, log data that's not accessed frequently, or large data sets that need to be retained but infrequently accessed. Archive is best for data that needs to be retained but not used, such as medical or accounting data that needs to be retained for regulatory requirements. Data can be moved between tiers, and the default tier can be set for new data added to a storage account. We'll move on to data protection next. There are a few options for data protection beyond storage redundancy. First, soft delete is enabled on all storage accounts by default. This protects data from accidental deletion by maintaining the deleted data for a specified amount of time. Think of this as a recycle bin for blobs. There's a retention period set for soft deletes. During this time, deleted data can be recovered. Soft delete can be enabled at the container or at the blob. Recovering a container will also recover all blobs in the container, so it's best to enable soft delete on both if individual blobs need to be recovered. Another data protection option is blob versioning. Blob versioning automatically maintains previous versions of blobs, allowing us to recover previous blob versions. Every write to a blob will create a new version of the blob. Keep in mind that each version adds to the total amount of data stored in the account and will increase data storage cost. Be aware of this for data that's modified frequently. Last, we have snapshots. A snapshot is a read-only copy of the blob taken at a point in time. Snapshots are similar to versioning. However, with versioning, a new version of the blob is created every time it's changed. A snapshot is created manually or by some automation or application to create a point-in-time version of the data. For example, let's say we have a blob with versioning enabled and daily snapshots. The blob changes 5 times a day. Versioning would capture all 5 versions, while snapshots would only capture the versions available at that point in time. Also, we could enable both versioning and snapshots, but it's not recommended. It doubles the data because all versions are added to the snapshot and doesn't add any real value. It just inflates the amount of data consumed and adds to the storage cost. Finally, we have several options for managing blob data in Azure. Most programming languages have libraries that can interact with Azure blobs. There's also PowerShell and the Azure command line interface. We can even interact with blobs directly from the portal. In the demo coming up, we'll review 2 options. The first is AZCopy. AZCopy is a free command line utility that can copy blobs to or from Azure storage accounts. It can also copy data from Amazon S3 and Google Cloud Storage. Next is Azure Storage Explorer. Storage Explorer is a standalone GUI-based application used to manage Azure storage. It works with Windows, Mac, and Linux. It's a free utility available from Microsoft. We can interact with storage accounts, blob containers, file shares, queues, and table storage with Storage Explorer. It even has a local storage emulator, so we can emulate a storage account on the local computer. The difference is that AZCopy is a command line tool and Storage Explorer has a graphical interface. Let's jump into the Azure portal and start by creating an Azure storage account. Here we are in the Azure portal. Let's start by going to Storage Accounts. We'll add a new storage account. Select the subscription and the resource group, or you can create a new resource group if needed. Give it a name. Since this is part of URI, it has to be global unique and contain lowercase letters and numbers only. Select a region, Central US for this example, and set the performance tier. With standard, we get the options for LRS, GRS, ZRS, and GZRS storage redundancy. If we set it to premium, we can select block and page blobs or premium file shares. With the blob option, we only have LRS. Now, if we change the region to East US, we get the ZRS option as well. Not all regions support zone redundant storage. Let's set it back to standard, and we'll set it to ZRS. Click Next to go to Advanced. We'll leave most of these set to default. Notice that by default, anonymous access to blob containers is disabled. There are some use cases where public web content is hosted in an anonymous container. We might want to enable this if we're hosting public data. It is good, though, to leave this off by default. We want to prevent someone from accidentally hosting private information in a public container with anonymous access. That's how security breaches happen. Another item we can allow is cross-tenant replication. We can also define the default access tier, hot for this example. Let's click Next to go to networking. Here we can enable or disable public access. We can also enable a firewall and only allow access from specified IP addresses. Let's go to data protection. Soft delete for blobs, containers, and file shares is on by default. We can also enable versioning of blobs. Let's enable that. There's also an option to enable a change feed. This is a log of changes to the blob file. Let's go next to encryption. By default, Microsoft manages the keys for data encryption. Alternatively, we could supply our own keys for data encryption. This is an added layer of security as Microsoft doesn't manage the keys the data is encrypted with. We can limit customer managed key encryption to blobs and files or all service types. We'll go next to tags. Add tags as needed and go to review and create. Once validation passes, click Create to create the storage account. This shouldn't take long. I'll pause here and come back once it's finished. The storage account has been created. Let's go to the resource and create a container. There are a lot of options in a storage account. For this video, we're sticking to container and blobs. Let's go to Containers under Data Storage. There is a default $log container. Let's create a new one. We'll click Create a new container. Let's call this one Data. No capital letters on a container. We didn't enable anonymous access when we created the storage account, so that option is grayed out here. Click Create to create the data container. And there we have our first container. The storage account is private, so we need to authenticate to manage the data. We can use RBAC roles with Enter ID, or we can use a secure access string or a SAS token. Let's do that next. Click the three dots on the right of the container and select Generate SAS. From here, we go to permissions, and we're going to give this token every permission but immutable storage. Notice, however, we could create a token that allows for read access or read-write access without the ability to delete. We can set a range of times for the SAS token to work. We can also specify allowed IP addresses. Change the expired date to a couple days in the future. Then generate the SAS token and URL. That gives us both the SAS token and the blob SAS URL. Copy and paste both of these someplace safe. We'll need them shortly. Once you leave this page, you cannot access these strings again. You can create another new one, but you can't view existing strings. I'll copy both of these into Notepad. There's the token. And there's the URL. We'll need both items coming up shortly. We can close this window now. Let's add a couple blobs to the container next. And to start, we'll use AZCopy along with the SAS URL we just created. I'll add the download link for AZCopy below. For this example, I downloaded and extracted the file and moved the executable to the downloads directory. I'll run this from the download directory. The command to copy data is pretty easy. We'll run AZCopy with the copy command. Specify the source and destination. So we have the source. There's the source. Next, we'll supply the destination path. And make sure that the source and destination are in double quotes. And hit enter. And that looks good. Our container is private and we didn't log in. For the destination, we use that SAS URL. That's the one that starts with HTTPS. We granted read-write access when we created the secure access string. Let's see if the file is there. We'll go back to the storage account in the portal. Open the container. And there's our file. We uploaded our first blob file into the container. There are a lot of other commands and switches with AZCopy. For example, we could use the recursive switch to upload an entire directory. Let's move on to Storage Explorer next. This is also available from Microsoft. I'll leave the download link below. We're going to use our Enter ID account to log into the storage account, but before that, let's see how we can connect to a storage account with the SAS token. Go to Attach. There are a few options. Select Blob Container or Directory. Select SAS URL. Next. Paste in the SAS URL that we created earlier. That's the same one we used with AZCopy. We can also update the display name if we want. We'll go to Next. And Connect. We are now connected with the SAS URL to the container. This option works great if you want to share data with someone outside your organization, but you don't want to provide an account. Remember, we can also set the type of access on the SAS token. We could give somebody read-only access, for example. We're going to detach the container next. We'll use Detach to disconnect the container. We'll go into Actions and Detach. And let's refresh. Next, we'll log in with our Azure account. We'll use Sign in with Azure under Getting Started. Follow the prompts to log in. It will redirect to a web page for authentication. Okay, that just took a second. I'm logged in. There are a couple of Microsoft tenants showing because I logged in with the guest account on multiple tenants. I'm going to unfilter the subscription that is my personal tenant. And I'll also remove the subscriptions that aren't part of the example we're working on today. Now if we go to Explore, we can drill down to the storage accounts in the subscription. We'll locate the test storage account and the blob containers. That was CIR blob test for my example. And we'll go to blob containers. And data. From here, we have a few options for interacting with the data in that container. Let's upload a file. For For this example, I created a text file called Storage Explorer. Notice we can set the access tier value. We can also use virtual directories. Click Upload to upload the file. And there it is. Storage Explorer gives us a familiar Explorer interface for managing Azure storage. I'm not going to go over every option here, but if you made it this far, you can probably figure out that the download will download blobs, properties will show blob properties, and so on. Let's create a version next. We'll do that by modifying one of the blobs on the local storage. This example will use the file storageexplorer.txt. Let's open that file. And we'll change it. We'll save the change, and then we'll upload a file. We'll select the file we just changed, and upload. When we get the prompt, replace the file. Once we've replaced the blob file with the new version, select the blob. Once we select that, we'll go to More, Manage History, Manage Versions. We enabled versioning when we created the storage account, so a new version was created automatically. If we select the previous version, we can go to Preview, and there it shows the content of that version. One last note before we finish. Let's go back to the storage account in the portal. We'll go to Data Management, then Data Protection. Under Tracking, Enable Versioning is set to keep all versions. You may want to set this to delete versions after a certain number of days. Each version will add to the cost of storage. Will it save? From here, you can also modify the soft delete settings for blobs and containers. That's the beginner's guide to blob storage. There's a lot more to cover on this and other Azure topics, so please subscribe and hit the bell icon for notifications of new content. Thanks for watching.